Hello everyone. Welcome back to the course on Learn to Read Architectural and Structural Drawings with ETABS. In the series of lectures, we'll be trying to know how the ETAB functions. We'll be trying to see various commands of the ETABs and we'll try to understand them one by one. So we'll quickly get into the ETAB software and we'll try to explore how the ETAB software functions. Yeah. So we already seen how the ETABs look. So this is the screen of ETABs. Once you open the ETABs, so this is how it's going to look. So the moment you open it, what you have to do, just go to the file command, the file, and from here we'll start with a new model. So click on new model. Yeah, the moment you click a new model, you're going to get three options there. The first one is the use saved user default settings. The second one is use settings from a model file, and the third option is use built-in settings with. Though this first option is not so much useful for us, we can't do any modifications there. The only options that we have is the second one, that is use settings from a model file and use built-in settings with. So when do we use this use settings from a model file? See, listen. Now let us say I have already the plans what we saw right now. It's a G+3 residential building, right? So that was done for one of my client. Now there is a one more client of mine who has come and who wants to do almost a similar kind of plan. So similar kind of plan, similar kind of building he want to construct. So then what I will do, instead of sitting for the whole day and doing the grid lines and applying the load and all, what I would do is I'll go to use settings from a model file. Means already have done that file, right? The same file I'm going to pick in. So I'll select on use settings from a model file and I'll click on OK. So the ETABS is going to ask me where you have saved it. So I'll tell to ETABS that I've saved it somewhere here. I'll click that particular file. Okay, so wherever you have saved that file, just go there and click there, and from there hit on the button open. The moment you open it, these are the grid lines what is going to come. We'll not try to get into the grid lines here, right? And click on OK. So what has happened, the grid line has come here, but whatever load I had given there, whatever materials I had defined there, like M20 grade of a concrete and Fe415 Fe500 grade of the steel I had mentioned, then I had given the load combinations, all those things by default it will be taken into this model. So we'll try to see that. See, we'll go to define, we'll go to material properties. I did not do anything now. So what has happened by default, since I took that model file, I am getting a M40 here, I'm getting Fe415, I'm getting Fe500 here, I'm getting M25, M30 and M20, right? So by default the ETABS will take that. So in a process what is happening, I don't have to spend my time in entering this or adding this new material again and again. So this is the importance of using a model file. So along with that, let me say I'll go to define and I'll go to load pattern again. So in the load pattern, what has happened, so by default, since it was a model file, the dead load has come on its own, the live load also has come, and the SIDL load, that is superimposed dead load, has also come, right? So whatever I used in that model, and the main advantage of this is that you go to define and go to section properties and go to frame sections. What you have to do, go to define, from there go to section properties, and from there go to frame sections. Now what has happened, luckily we have got all the sections that we already defined in that model. Otherwise, now imagine you want to sit and define all these sections, that is B150 by 300, B300 by 450, beam 300 by 750, a column of 300 by 450, a column of 500 by 500. So it will take a long time for me, since I've created a model file. So whatever dimension I want to use, now I have that privilege to just select here and assign it to the model, right? So these are the advantages of taking a model file. And the grid line, this whatever grid line you want to do, you can add it, or you can just import the grid line, right? So this was all about how to what is the use of that second option, that is from a model file. Now coming to the next option, we'll go back again, file, new model, and I'll say no to this. And yeah, the third option what is left is use built-in settings with. So when I say use built-in settings with, I don't have any model file with me. This is the first time I am using the ETABS software. Then what I'm going to do, I'm going to select this option called use built-in settings with. If you're using it for the first time, or let us say this model file what you've created here, that is of no use to you, maybe the project what you're doing right now, maybe some other project, so in that case this will not become handy for you. In that case it's all okay. you go for the use built-in settings with option, and it's asking you what is your display unit, how you want the units to be displayed. Usually what we use is the metric SI system. There are if people from US, what they try to use is the US customary. If you want to use that, you can use that. Or let us say you're working on a projects of a US projects. In that case, people use this. But whereas we actually try to use metric SI system, so I select on metric SI system. Next, coming to steel section database. So the system is asking me, the ETABS is asking me what kind of steel section database you want to use. So there are a lot of different countries where we use ETABS. So if you look here, uh, since I'm teaching you from India, what we usually use is we refer Indian codes. Similarly, if you're from the Europe, from the Euro side, then you can make use of the Europe code. Similarly, if you're a Korean, then you can make use of the Korean code. If you're from the Russia, you can make use of the Russian code, right? If you're from the British, then from the UK part, then you can make use of the BS shape. This is a code book these are the code books for the steel section database. AIS stand for American Institute for Steel. Yeah, I don't know what C stands for. Yeah, it's American Institute for Steel Composition, I would say. Let me try to check it. Let me check it. I'm not sure. Yeah, it's American Institute of Steel Construction. AISC stand for. I'm sorry for that. American Institute of Steel Construction is what AISC stand for. Yeah, usually we don't use that, so I don't remember. I don't remember the formula. I mean the full form. Yeah. So that is what I'm selecting. It's a Indian. Next, coming to steel design code. Again, he's asking you which steel design code you want to use. So since again I'm staying in India and we refer Indian standard A800 2007 is a code book what we refer here. So I'll select on that. If not, if you don't want to use that, and if you belong to some other country, you can make use of this. BS stand for British Standard. You have Euro code. You have Italian code. You have KBC, that is Korean Bureau code. You have NZS, that's for New Zealand code. SP16 SP16, then SP16 I feel it's a Russian code, right? Yeah, SP16 I feel it's a Russian code. So what different countries follow different code. So we'll try to strictly um, go with IS code, that is IS 800 2007. Next, coming to the concrete design code, again we refer here IS 456 2000 is a code book what we refer. If you're from US, then people use American Concrete Institute. Then there are 3 4 like ACI 31814, ACI 31811 is a code book what they have. Then BS have their own code, that is British Standard 811097 what they have. And then they Hong Kong, they have Italian, they have Korean Bureau code, they have Mexican code, they have New Zealand code, they have Singapore code, they have Russian code, and so on. So and they have Hong Kong code as well. So whichever country you belong, you can refer the code book and you can start to design with the help of ETABS software. So as of now, I'm taking IS 456 2000 and I'll hit OK button. So the moment I hit OK button, the ETABS is going to ask me all these things like how your grid line should be, what should be your center to center spacing of your grid line, how many number of stories, like how many number of stories you want to put up, what is your typical story height, what is your base height, right? All these things ETABS is going to ask me. As of now, I'm not going to get into this. We'll directly hit on OK. Let that random grid line come up. We'll see that after some time. So this is how the grid line is going to come. So right now what you can see here, right? So this is a plan view. Plan in the sense I have a plan in the sense I have a drawing with me. I'm looking it from here. I'm looking from the top. So how the plan is going to look, that I can see here. And this is a 3D view. If I look at the building here, how the building is going to look from the 3D point of view, I'm going to get the entire picture of the building here, right? So yeah, now we'll try to see how the user interface of this ETABS is all about. Yeah, one thing we need to understand before getting into the ETABS, you look at the axis here, you can see the axis, these are called as global axis. These are called as global axis. What is there? X is here, Y is here, and this is Z. What is trying to tell is, this is my, yeah, this is my X axis, this is my X axis, this is my Z, this is my Y axis, which is perpendicular. This is my Y axis. This is my x-axis, and the height what you measure, that is in terms of z-axis. Let me repeat it again. This is my x-axis, this is my y-axis, and this is my height is a z-axis. But if you know STAD Pro, STAD Pro is another software where we also try to design RCC building, steel structures and all. In STAD Pro, X remains the X. Whatever X you have in ETABS, it's the same X axis in the STAD Pro. But whatever Y I have in ETABS, that is Z in STAD Pro, and this Z what I have in ETABS, it's a Y axis in the STAD Pro. If I want to put it in a very simple form, X is X axis in STAD, this is Z axis, and this is Y axis. Whereas in the ETABS, this is X, and this is Y, and this is Z. So whatever Z I have, that will become Y in ETAB, and whatever I have, that becomes Z in the STAD Pro. But just I wanted to tell you how the difference is all about. So we'll strictly restrict it to this global axis, that is we have X, we have Y, and we have Z axis, right? Yeah. Other than that, one more point what I can add here is, see, the background right now it's white in color, isn't it? Now let us say you want to change the background here. So what is a simple option to do that? Go to the option, go to the option, okay, this option. From there go to graphic colors. What you do, go to option, go to graphic colors. From there go to display. So in the display, forget about all these things. We'll try to do all these things if possible. Just come here. You can see an option here, that is a screen written here. And what is the background here? It's written white background. Let us say I don't want the white background. I want a black background. So I'll click on black background, and I'll hit OK. So by the moment I turn that into black, what has happened? The background what I can see, it's a black in color. So just in case if you feel like you want to have a black background and you want to give a different color to the beams, the columns, the sections, then it's going to look good. So this is usually what we try to do. If you want, you can change the background color. Yeah. And all these are the options what we have. We'll see all those things in the upcoming lectures. All these are the options what we have. The file command, the edit command, we have view, we have define, we have draw, the select, assign, analyze, display, design, options, tools, help, etc. Right? And yeah, so right now I'm in the plan. So that is why I can see only X and Y. So this is my plan. I have only X and Y. If it is a 3D, I'm going to get even the Z axis as well, right? Yeah. So this was just about overall, view of how the ETABS software looks and how we need to understand the graphic colors and all the tools what we have here. So in the upcoming lectures, we'll try to dig more and more about how the various various function works here. And we'll see you back in the next lecture. Thank you. Hello everyone. Welcome back to the course on Learn to Read Architectural and Structural Drawings with ETABS. In this lecture, we'll try to see how the grid lines has to be done with the help of ETABS software. So by default, what has happened? We have got all these kind of grid lines, right? So now what we'll try to do, we'll try to take one particular example. We'll take this example, right? I have drawn a grid lines here. I will try to uh, model the same kind of grid lines into the ETABS software. So we'll go to the ETABS again. So what I have to do is I have to go to the option called edit. Since I'm going to edit it, edit. From edit, this option called edit stories and grid system. You have to go to edit. Whenever we want to do any editing option, we have to go to edit, and from edit go to edit stories and grid system. So by default, you have a grid system here, which is called as G1. So I need to modify that. So from here, what we have to do is we have to go to the option called modify or show grid system. If you want to add a new system, then you have to click on the option called add a new grid system. But since I'm not adding a new grid system, there's already a grid system here. I just want to modify the same grid here. So I'll click here on the G1. Here, okay, there's the option called modify or show grid system. Click there. Once that is done, we have a lot of options here. As of now, we'll not try to get into that. We'll try to see how we want to model the same thing into the ETABS, right? So you have the grid ID here. It is given A, B, C, D, and so on. And these are my X grid data. These are my X grid data. Similarly, I have a Y grid data, You can see a Y grid data here. So naming given is 1, 2, 3, and 4. Right. So these are my X coordinate. Since I'm in X axis, I'm in X grid. So these are my X coordinate. I'm in Y, since I'm in Y grid data, I get a Y ordinate here. Now the first ordinate will be always 0, 0. We already always seen this, a Cartesian format, right? A 0, 0, a 0, 2, 0, 3. That means I'm going parallel to the x-axis. When I say 3, 3, I'm going 3 steps in x-axis and 3 steps in y-axis. That is where my point is going to lie. So the same thing we have to do it here. For that, we need to understand the drawing what is given here. See, this is my A, this is my B grid line, this is my C grid line, this is my D, E, and F grid line. Similarly, I have this one grid line, this is two grid line, this is three grid line, this is fourth grid line, and this is fifth grid line. So the grid line 1, 2, 3, 4, 5, all these are horizontal grid lines, and the grid line A, B, C, D, all these are my Y grid lines. So first we'll try to see the X grid line, right? So if I'm standing here, let me do it here. Yeah, if I'm standing here, what is my ordinate? It's a 0, 0 here, right? It's a 0, here. By the moment I come here, how much I have traveled here? 6 meter I have traveled in X direction. But whether I have traveled in Y direction? No, right? It's a 0, 0. I'm coming straight. So this axis will be 6, 0 here. Similarly, when I come here, how much it will be? 6 plus 6.5 comes out to be 12.5. So it comes out to be, I'll write it at 12.5, 0, right? Similarly, when I come here, what will happen? 6 plus 6.5 is 12.5. 12.5 plus 3.3 is 13.5, 14.5, 15.5, and 15.8. So this will be 15.8, 15.8, comma 0. Why it is 0? Because I am not moving in the y-axis. But the moment I come here, now we'll try to see what is this coordinate now. See, first is x. So how much in x I have done the movement? I have done a movement of 6 meter. So I'll write here 6, comma. What is y? From here I have come down. How much I have come down? I have come down by 3 meter, right? I have come down by 3 meter. So it will be a 6, 3. So this is how I am going to give the points for doing this, right? So we'll do the same thing in the model now. I'll go to ETABS model now. So I'll try to delete everything. Yeah. So first is always 0. So I'm inputting as, okay. Yeah. So this is 0 here. Now coming to the x. So we'll take the figure again. So what is this point here now? It is 6, right? So from here I move to 6 meter. So what I'm going to do in B, I'm going to input 6 meter. Next, coming to the next point. What is the next point again? So from 6, I want to put this point. I want to mark this point now. How much is this point now? 6 plus 6.5 comes out to be 12.5. So what I'll do, I'll input here 12.5. I'm going only in x-axis now. Next, coming here. After that, now I'm here right now. Yeah, so right now I'm here. So how much it will be? 6 plus 6.5 plus 3. How much it is? 12.5 plus 3.3 comes out to me 15.8, right? So I'll go here. I'll input here 15.8, right? So after this, I don't have anything here, right? So what you have to do? There is an option called add. So I'll add it here. Let me add thrice so that I can make use of it. I'll add only twice. So by default, some value will come. We'll not take that. After 15.8, what is the next thing? 15.8 is here. I have to add another 7.6 for that 15.8, right? 6 plus 6.5 plus 3.3 plus 7.6. So instead of doing all those things, what I can do directly in the ETABS, I have 15 point here, right? 15.8 plus how much I have to add again? If I add 7.6, I'll reach here. So I'll add another 7.6 in the ETAB itself, and I'll hit enter button. So by default, ETABS will do this calculation. I'm getting 23.4. From here, again 23.4 plus what I'll do, how much is this? 5 meter. So I'll reach to this point. So I'll hit 5 meter there and click on enter. So the X is already all done. Now we'll go back to the Y now. From the Y, we need to understand one thing. See, yeah, so always the first will be 0 now. Now coming to the second one, Now I have to go along the y-axis. I have to go along the y-axis now. I have to go along the y-axis. X-axis already done. I have to go along the y-axis. So in the ETABS, by default, when we go through y-axis, the first point will be taken from here. The ETAB considers, the ETAB follows this pattern. That is, while calculating the x, it moves from left to right. While calculating the 6.5, 3.3, it moves from left to right, and while calculating the y, it moves from bottom to the top. That is why what we try to do, first will be my 0. I'm starting from here. So 0, if I want to come to this point, how much I should add? 0 plus 5.3. That is, if I put 5.3, I'll reach to this point. So what I'll do here, I'll add 5.3 here, right? And after that, what about this point? 5.3 I reached here. If I want to come to this point, how much it will be? 5.3 plus 4.6, then I'll reach here. So what I'm going to do, 5.6, yeah, sorry, yeah, 5.3 plus 4.6, right? 5.3, yeah, 5.3 plus 4.6. I'll reach here. I'll hit enter. I'm getting 9.9. So 9.9 plus, I hope it is understood now. 9.9 plus, if I add 2.3, I'll come here. So I'll enter 2.3 here. Yeah, so I got 12.2. Now I don't have any other grid here, so I'll go here and add. I'll hit it twice, so that I need 2. So I'll again add 12.2 plus. So if I add another 3 meter for 12.2, I'll reach to this point, right? I'll reach to this grid 1. Yeah, grid 1 here, or A, I'll reach here. So I'll add another 3 here. 12.2 plus 3 meter I'll add, and I'll hit enter. So this is no more required now. Since I added another additional one, it's no more required. Just go here and hit on delete button. So it will be deleted. And what you have to do is, once all the entry is done, we'll hit OK, and we'll hit OK here as well. So whatever grid line I've drawn here, let me delete this. I'll delete this for a while. Yeah. So you can see the grid line here. Let me change this into a black background so that it is visible. Option, graphic colors, go to display, and white background, I'll change it to black background, and I'll hit OK. Yeah, now it's visible, right? So what has happened? Whatever grid line I needed here, isn't it? It was 6, 6.5, 3.3, 7.6, and 5. Look here, and same thing has come here. 6, 6.5, 3.3, 7.6, and 5. It was 7.6 and 5. Coming in this way, I have a 3 meter here, a 2.3, 4.6, and 5.3. So the first one is 3 and 2.3. So you can see a 3 meter here. You can see a 3 meter here. You can see 2.3 meter here. Then can you see a 4.6 meter here? And what is the last value? What you have? It's a 5.3, isn't it? I hope it is visible. It is 5.3. So whatever you can see there, 5.3. The same was, the same was here. The same grid what I wanted here, the same has come here, right? So this is a grid line what they have to. So what is the use of all this grid line? Now let us say this is a kind of a plan what I've done. I'm taking a rough plan. It's not a right plan, but let me explain it. And let us say I want to put a kitchen here. I want to put a kitchen here. Okay. And let us say I want to put a bedroom here. I want to put a bedroom here. So this is a plan given. So whatever plan was given, these are the grid lines what I require. And let us say I have a living hall here. Okay, I'll write formal room. Formal room. Hope whatever I'm writing it is visible. And then let us say this is a kind of a dining hall what we have. This is a kind of a dining hall. I'll write it here. I'll put a small puja room here. A small put, but anyhow, this plan is not according to Vastu. As I always tell you people to follow Vastu. Randomly I'm putting a plan. I'll put a puja room here, and this is a, let us say it's a dining hall somewhere here. Okay, I'm giving a random thing. It's a dining hall. Dining hall. Okay, I hope. And let us say you have some, there's attached from here. You have a kind of a toilet here. Yeah, you can put a toilet in this portion according to Vastu. No issues. You have a toilet here, and let us say this is the open space, and you make an entry from here, right? Yeah, this is a kind of a plan what we have, and this is a grid line what I require in order to make a plan something like this. So what I've done, based on this grid line, based on this grid line, based on this grid line, I'll delete it. I put a plan something like this, right? So this is my plan, right? So this is how we try to play with the grid line. I want to add one point here. We'll go to edit. We'll go to edit stories and grid system. Just in case if you want to make some changes here, you don't want a 6.5 meter here, you want to make it a 7.5 meter. Then how do you change all those things? Go to edit, go to edit stories and grid system again, and here it's a grid system what I have. Go to modify or show grid system. So whatever you have entered here, right? So those value you can change it. Instead of 6, you calculate that value what you want to input, and you can input that here. That's it. Yeah. Now coming to this point, just concentrate here. What is written here? Quick start new rectangular grids. I'll click it here. So by default, what has happened in the ETAB, you can see the X grid labeling. You can see the X grid labeling. What is the labeling name given? A. That is why in the X grid labeling, you get a first name has A here, right? And similarly, what is Y grid labeling? By default, first grid labeling is 1 here. That is why in the Y, the first grid labeling is Y here. The first grid labeling, what you can see is 1 here. Now just in case, now concentrate here. What is the labeling direction? It is given left to right. Where? For the X grid. That is why we took the counting from left to right for the X. But whereas when you came to the Y grid labeling, you had a labeling direction from bottom to top. That is why I told you to come from bottom to the top. So this is what the ETABS follows. But if you don't want to follow in this way, you can come here at any time. And if you don't want the first grade to be A, I'll give T has my first grade. Let us say T has my first grade, and I don't want to go from I don't want to go from left to right. I want to go from right to left. I can do that. ETABS will allow me. And if you, and the Y grid labeling, you don't want it to be 1. Instead, let us say you want something like 21. Let me do 21, and I'll tell ETAB I don't want the labeling direction from bottom to top. I want it from top to bottom. Once everything is done, hit on OK. This will change, not an issue. And I'll hit on OK. I'll hit on OK. So what has happened? Any of the grid line has got changed. You can see this. Look here. What has happened? W has come here, V has come here, U has come here, and T has come here. And from here, the labeling you see, it has come. Yeah, sorry. I'm sorry for that. Since in the x-axis, what we have done, initially it was left to right, but we change it from right to left. That is why you can see here T, U, V, W. That is, you are coming from right to left. Similarly, look at the Y. The 21 number is starting from here. That is 21, 22, 23, and 24. Why? You told ETABS that the Y direction has to be from top to bottom. That is why you are having 21, 22, 23, 24. If it was from bottom to top, then you would have got a 21 here, 22 here, a 23 here, and a 24 here, right? So this is how we try to put the grid lines, and this is how we need to understand them. We'll see you back in the next lecture. Thank you. Hello everyone. Welcome back to the course on Learn to Read Architectural and Structural Drawings with ETABS. In this lecture, we'll try to see how the floor level is to be assigned. That is how to write the first floor, the second floor, the third floor, and so on. And we'll also try to see few more, commands in the ETABS, and we'll try to understand them. So we'll quickly get into that. So this is how my ETABS model looks now, right? I have a tab model. So this is what basically we did. Now, one thing we need to understand, what is that? See, you have only a plan here, right? You don't see a 3D window here. If you want to see the 3D window, it has disappeared. So there's an option here. You can see option here. Just click on that option, and there is an option called add new window. Just click on the add new window. So one more window is going to come up. So this is my 3D window, and this is my plan window. Now let us say you want to add one more window, right? So you can just go here and add one more window here, add a new window. So what will happen? You're going to get one more window here. Let us say you want to add one more window. Just go there, click add new window. So you're going to get one more window. So let us say you're working on some big projects and you want to see the 3D view of that, and you want to see how the beams are going to look and all. In that case, all this a different, I mean, the 3D view comes into picture. As of now, I'll try to remove that. Another thing, along with that, I have a plan here. I have a 3D here. Let us say I want to see the elevation as well, only the front view. Like if I'm seeing a building from the north side, how it's going to look. From the south side, if I'm looking, how it's going to look. So what you have to do, just click on any one of this. I'm clicking on this as of now. I'll click on this. You can see it's activated. See, wherever you click, that gets activated. If I want to work on this plan, I have to click here. So then this plan view gets activated. Then only I can do any changes here. Now I want to make a change in this particular window. I'm clicking it here. So it's a blue in color. Now this option here, can you see here? So it is written 3D. That means if you want to see it in 3D, you have to click on 3D. Then there is something called plan. Now what I'm going to do, let us say this is a 3D. I want to convert this particular window into plan. So I'll just click here and there's an option called plan. Click on the plan. So the system is asking me which plan you want to look like. See, right, this is a plan what you have, but you are seeing the 4-story plan. Let us say I want to see my first story here. I want to see how my first story, that is first ground floor is let us say story 1 is going to look. I'll click on the story 1 and I'll say apply. The moment I put apply, so what has come? It has the 3D model has turned into a plan. Which plan is that? It's a story 1. Here also it is in plan only, but here it is a story 4, right? Now let us say I want to change this 3D view from here into elevation. I'll click here. I'll go to this option. It's written ELEV. It's written for elevation. I'm clicking on the elevation. Now the system is asking me from which side you want to view it. Whether you want to view it from the grid line 24, 23, 22, 21, or you want to view it from the grid line W, V, U, or T. Like it's asking you want to view it from here, 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 or here. So I'll take random. Let us say I'll take 24 is a view I want. I want to see my building from here. And I'll hit on apply. So what you can see, can you see this elevation here? That is, this is your base. You have a story 1 here. This is your story 2. This is your story 3. And this is your story 4, right? So in one single window, I have a plan here of a of a fourth floor. I have a plan here of a story 1. I can see a 3D window here as well. There's a 3D window here as well, and I can see the elevation. So if you want to work in this way, you can create new windows and try to work on this. But usually we don't try to do all those things, since it's a designing and a detailing and analysis software. A plan and a 3D is enough for us. So this elevation and all comes handy if you're working on some projects, like if you're working on drafting softwares like um, AutoCAD, or let us say Revit or Google SketchUp. In that case, this comes into handy. But here usually plan and this 3D view is enough for us. So if you don't want that, just click here and just hit a X mark here. Just click here and hit the X mark here. So now right now I want this in plan. Let us convert this into 3D again. I'm hitting it here. It has got activated. Go to the 3D view. So it will be converted into a 3D view, right? Yeah. So now I'll try to, this is a small bug in this software. Just click on plan again and take any one of the story. It will come back to normal, right? So yeah, fine. So now I'll try to change the story. See, right now what is happening, you look at the plan. You have a story 1 here, you have a story 2 written here, you have a story 3 written here, you have a story 4 written here, and it is written base here. It's not a right way to define the floors. What we define is like a foundation, a plinth level, a first ground floor, a plinth level, or then we say, let us say, first floor, second floor, third floor, right? So these are the drawings usually what we saw. It is a first floor beam layout, second floor beam layout, third floor beam layout, terrace floor beam layout, LMR or the overhead LMR portion, right? This is what we try to solve. So that is why what I'll do, I'll try to change them. For that, since I'm changing it, I need to go to the edit option. In the edit, there's an option called edit stories and grid system. So I've gone there. Right now, I mean, I'll not go to the grid system this time. This grid system is to play with the grid lines here. This time I want to play with the story heights and name of the story. So you have to go with story data option. You have a story data option. It's written base, story 1, story 2, story 3, and story 4. I want to modify that. See, if you want to, okay, first let me modify that. I'll go to the option called modify or show story data. I'll click on this. The moment I click on this, a new window pops up. This is how it's going to look. So base, I'm telling, I don't want it to be base. I'll make it as foundation, because that is where my soil footing is going to rest. I'll write it as foundation. Story 1, I'll tell it is my plinth level. So I'll write plinth level. Then story 2, I'll say it's not it. I'll say it's a first floor. I'll say it's a first floor, right? Then I'll say it's my second floor. I'll write in this way, second floor. Then I'll say it's my third floor. Let us say I'll write it as third floor, right? So now let us say the plinth level is, let us say I want to change, it's a floor to floor height, what I'm going to keep. So from the foundation to the plinth, usually we keep 5 feet, that comes out to be 1.5 meter. And all the typical floor, that is first floor to second floor, all this is usually what we keep is 3 meter is floor to floor height. Few times we try can keep it as 3.1, or you can keep it as 3.2 also, based on the requirement. So this elevation, what you can see, it is going to give me the total height of my building. The total height of my building is 10.7 meter. Forget about all these things. Master story, similar to splice height and story. We'll not try to get into this, right? So I'm done with the third floor. Now let us say I want to add one more floor. Then I'll click on OK here. Before that, this is the third floor here. Let us say I want to add another 3 4 floors. What I'm going to do? You have two options. Click OK here. So that changes happened here. You got foundation, your plinth level, first, second, third. The first option is that there's a button here called quick add story. I'll just click on adding it. The number of times you add, the number of story gets created. I'm adding it once, so one story got created. I'll add it two. I'll keep on adding it. So what has happened? The story has got created, right? Now what you can do, go inside this modify or show story data, and third floor will convert this to fourth floor. I'll convert fourth floor. I'll convert this to fifth floor. I'll convert this to sixth floor. Let us say I'll convert it to seventh floor. Yeah, I'll write it as seventh floor. Okay, let me make it seventh floor, and we'll do it as eighth floor. Yeah, we'll make this as terrace portion. Yeah, we'll make this as eighth floor. Eighth floor. Okay, and let me make this as a terrace portion. Terrace. And this portion, what we saw, terrace spelling. Yeah, terrace portion. And this floor, what we saw in one of our drawing, we had written LMR, that is called as lift machine room, or you can write it as headroom, HEAD, headroom, or you can write it as overhead tank also, OHT, overhead tank. That also sometimes we try to write, right? So this is what I've written. I just have to click OK here. Just in case, let us say your headroom distance is not 3 meter, you want to reduce that height. Usually that is what we try to keep. We don't keep floor to floor height of 3 meter from terrace to the headroom. We try to reduce that height, since very less, I mean, we don't go there frequently to the overhead room and to the lift machine room. So instead of that, we can keep 2.5 meter here. So I'm keeping a 2.5 meter. The moment I put 2.5 meter, look at the elevation. It was 31.7 here. It will change, and it has come to 31.2. So this is the total height of my building, right? So once everything is done, I'm going to hit OK button here, and I'm going to hit the OK button here. Look at the 3D window. Right now you can see only a foundation here, first, second, and three, right? But right now what we have done, we added so much of floors. I'll hit OK here. The moment I hit OK, what has happened here, you can see the story here. A lot of stories have been created. So number of stories, whatever you create over there, those stories will come up here, that will be shown here. This is a small bug usually that ETABS has. You just have to click here again and go to the plan. And now what has happened, see, foundation, plinth, first floor, second floor, third, fourth, fifth, sixth, seventh, eighth, terrace, and you have a LMR or a headroom or overhead tank. I'll just click on OK here. So what has happened, right? So this is what I'm trying to get. Yeah, this is one way of doing. The other way of doing that, this is that, go to edit stories and grid system. Instead of adding a quick add story, you can go to the modifier story data. I want to add one more floor, let us say. So wherever I want to add, just you can see a kind of arrow mark here, right? Click here, click the right click here, and you can see an option called copy, paste, add story, delete story, and so on. So I want to add one more story over that. I'll go to add story, and I'll click on keep existing story heights. And he's asking me what should be a story height. Let me tell, I want to add a story height that should be a 5 meter. How many such has to be added? Let us say I want only one to be added. And he's asking me where exactly you want to add, whether you want to add it over the LMR portion or below that or somewhere there. So let us say over this only I need to add one more story. So that is why by default LMR has come. Let us say you don't want to add it here. Even though you selected here, the ETABS will ask you again whether you want to exactly add this story over this, or you want to add it in somewhere between fourth and fifth floor. Let us say I want to add it in between fourth or fifth floor. I'll click it here and I'll click on OK button. So what has happened? Even though I right click here, that story got created here in between the fourth and the fifth floor. And what was that height I had given? 5 meters is my typical height. That is why 5 meter is coming. Now let us say I'm adding what name you can give here? Fourth and fifth floor. So let me write something here. Anyhow, there's no floors in between fourth and fifth. I'll write something here just to understand. I'll write floor itself. Okay, it doesn't make any sense, but still it's okay. I'm writing a floor here, and look at the total elevation. It has changed to 36.2 meter, right? So this is also another way of adding, but the better option is always add it from here, quick add story, because there it will take more time for you to add. Just in case if you have missed one story in between any two story, in that case that option becomes handy. Otherwise, if you want to add more and more stories, just go here, quick add story. I'm keeping on adding it. We'll try to see. Okay, I'm adding more and more stories here. Let me add more than 50 stories. We'll try to see how my building is going to look. Yeah, yeah, it's done. I'll click on OK button. You can see a tall structure has been created, right. So this is how a tall structure has been created. How many floors I've created? I've created 77 stories. That is the reason you can see a tall structure has been created here. Now if you want to play with this dimension, whatever you have put, you can do that. I will not try to do that again. So this was about how you have to do the editing options. Just in case if you have missed, if you want to change all those things, you can do it. Yeah, quickly I'll take you to some of the commands here so that you get an idea, so that I don't want to keep on adding more sections in this particular lecture. Just we'll go through that. I'll be a little slower so that you will be able to follow me. So if you're going to the file option, uh, in the file option, what happens, you have this like if you're doing a model for the first time, you can go for the new model, or if you have any model with you, you can go to the open option. Then if you want to close, it's a close option. If you want to save the model, you can click on save and save the model. If you want to save the model with another name, then you can go with the save as option. Now this import option becomes handy when you have already an existing plan. uh, what actually I'm trying to tell is, let me see if I have any plans ready with me. Yeah, see, what I'm going to do is, yeah, see, so right now what we did, we created all these grid lines here, isn't it? But it will take long time for us to create a grid line. Since the grid line what we created was a normal grid line, which is like 6 meter 6 meter and so on, it was easy for us to create. When we work on real projects, this is not exactly what we try to do. What we do is, there is an option called file. You have to go to import, and from the import you have this option called .dxf dwg file of a architectural plan. You have certain, see, we saw one of our G+3 building in the AutoCAD plan. So that was my AutoCAD plan, isn't it? From that AutoCAD plan, directly I'll try to import that plan, and whatever grid lines I require, no, by default that grid line is going to come here. So what I'm trying to tell, let us say this is a plan what I have. We already seen this plan. If not, you guys you will be seeing in the upcoming lectures. See, this is a plan what I have a room here, I have a kitchen here, I have a dishwash here, I have a store here, there's a dining here, and so on. So I don't have to sit and do the grid lines here. 5 meter from here, add 5 plus another, I'll try to zoom in. See, I don't have to add 5 plus 7.2, add the thickness of the wall, add the thickness of the wall here, add another 1.8 meter. This entire grid line you're going to get. Then vertically you try to add. All those things we don't do practically. So what we do is, whatever plan I have, this plan I'll try to import. The same plan what I have here. Right now it is in the PDF format, but we should have it in the AutoCAD format. In the AutoCAD format, I'll try to import that. So the moment I import whatever plan I have here, the same plan what I have, the same to same grid lines will appear here. The same grid lines will appear here, so that our task will be easy and we don't have to waste our time in putting these grid lines. So that is the importance of using this import command. So this is how we try to do. So the ETAB is giving us an advantage by if you have some plans in the Revit. So Revit is a software where we do the drafting work. So if you want to do it from the Revit as well, the ETABS is giving us that option that is here, revit structure.exe file. You can see you can import the plan even from the Revit software. And if you have some Excel sheets and all, you have some values and all, you can try to import all those things, right? So usually what we do is we use this option called dxf.dwg file of a architectural plan, or you can make use of this dxf file of a architectural grids. In the grid, only the grid line is going to come. In the architectural plan, the entire plan is going to come. Fine. Along with that, if you have a model here, you have a ETABS model here, and this ETABS model has to be sent to the other software. Like there is another software called Safe. The Safe, you can save, you can see option here, story has Safe. Safe is a software that is used for design of foundation and design of flat slabs. And if you have some big foundations like mat foundation, pile foundation and all, we make use of that software and we do the analysis and the design. Now from the ETABS, if I want to convert my if I want to export my structure of the ETABS into the save, then I have to click on this option called story has save, and this entire plan what I have created here, it will be converted. It will be taken to the save software. Again, in the save software, I don't have to do the same model. Just I'll try to export it from here. That is why you have option here as story has a save. Similarly, if you want to export it to the Revit software, you can do it. Similarly, if you want to export it to the AutoCAD file, you can do it. Okay. And other than that, if you like, this is another called etabs.e2k text file. Sometimes what happens, right now I'm working on a software called etabs, which is a 2018. Now I'm sending a file to one of my friend who is working on a etabs of 2015. He's still in the 2015 model, right? So I want to send him. So if I send this plan, it will not get open in his uh, ETABS model. So because of that, what I have to do, I have to send this E2K file. I have to go to here, export. You can see a file here, etabs.e2k text file. I have to send this file to that guy so that it will get converted and it will open up in his ETABS software of that 2015 version. So that is the importance of that particular option called as E2K file. So usually E2K file is what we do when we have change in the uh, change in the version of the software. Right now I'm using 2018. If I want to send it to someone who is still in 2015 version, then if I'm sending him directly this model, it will not open up that. We have to send him a E2K file. So that will be done with the help of export. And from here there's option called etabs.e2k text file. From here I'm going to send it to my friend. Yeah. Other than that, if you want to upload to CSI cloud, you can upload there. There's nothing technical in that. And if you want to see the project information, like which client you're working for, what is the project name, project number, the company name, the company logo, who is the engineer, who is the supervisor, those things if you want to input, you can input it here. And other than that, if you want to, yeah, project information capture, yeah, create report. So there is another called create report. If you want to see, right now we are not done any model here, we are not done anything much here. It is taking some time. Let us say you want to submit this model to your boss or someone, and is asking you what all things you have done. Then the ETABS is giving you a kind of a project report where ETABS will tell you, let me try to zoom in, where ETABS, will give you everything, what all things you have done. Like, see what all things we did here. It has coming in the form of a report. Like, we added everywhere the story 77, 76, right? We had given a height of 2.5 meter there. But from here, what happened? I'm going down. Hmm. Here what has happened, see, this was the input given by me. It was a terrace floor, it's a 8th floor, 7th floor, 6th floor, 5th floor, right? All these things I had given. So whatever I've done in my software, that will be taken as a report, and this report will be generated. So the best example would be, I'll go to the new model. I'll go to the new model. I'll say file, open. I'll save it once, and I'll try to open one more model. Yeah, I'll open the earlier model which we used to refer. So this model will help me to see how that project information is done, because here we are not done anything. We are not given the beams and all. So let us say this is a project what I have done. I'll go to the file. I'll go to the create report and show project report. So here I think it will take time. Yeah. So here what will happen? What sections you are defined? What is the load you are defined? All the things you are going to get in the form of a project. We'll try to see that. See. So this is how it is been created. We'll try to zoom out, zoom in 100%. You can see it here. See. Uh, you can see a base. You can see. I'll zoom in again. This is not from this project, it's an earlier project. See, you have created a base, there is a plinth level, there is a first floor, second floor, third floor. This was the force what is coming, and you had taken a dead load, right? And then what else? Yeah, so this were the beam sections what you had defined. This were the material what you had defined. All these things, everything is generated in the form of a table. And it is a report is created. All the calculations, everything will be mentioned here. So whatever you are going to do in a ETABS model, that will be uh, made in a form of a report. So this becomes handy if you want to submit a report and all, right? So this is the importance of doing this particular option. Yeah, other than that, there is nothing much to explain here. The rest options what we have here, we'll try to see that in the next lecture. I will see you back in the next lecture. Thank you. Hello everyone, welcome back to the course on Learn to Read Architectural and Structural Drawings with ETABS. In this lecture, we'll be trying to see a few more commands from the ETABS software. Yeah, so we'll try to close this. Yeah, so what we saw so far is only about very few commands we try to saw. So now coming to the edit command. So in the edit command, we have a command called edit stories and grid system, which we have already seen. Let me unlock the model. Yeah. So in the edit, we saw how to, the edit stories and the grid system is meant for all these things to change the grid system and to change the floor. That if you want to add first floor, second floor, and all, we can do that with that. Other than that, there's an option called paste, and then if you want to edit the frames, there's an option called edit frames and edit shells. So like if you want to join two beams, then you can go to edit frames and you can join the frames, you can divide the frames. This is what you can do. And you have a option called edit shells, where if you want to divide your slabs, and if you want to join the slabs, you can do all those things. We'll be taking up this in upcoming lectures. So I'm just giving you overall view how it's where all those commands are. And then coming to the view option, it's a set 3D option. Like one is we have here, it's a I'll take a different file. Yeah. uh, so in the view option, we have this option called set 3D view, isn't it? See, you can click here and make this as the 3D view. That is a one thing what you can do. This is how a 3D view is going to come. And other than that, we have a set plan view, then we have a set elevation view. Then if you want to change the axis, this will show you the axis. Right now I don't have any axis here. If I go to view and ask them to show axis, this axis is going to come here. That's x axis, y and z axis. And then other than that, these are the very simple options to zoom in and zoom out. Even that you can do even from here. Your options here, like zoom in and zoom out options you have. So in view you have only this much commands. Coming to the define, we already seen that. If I go to define, if I want to uh, insert the material like M20 grade of concrete or Fe500 grade of steel, I can define all the materials from here, like grade of concrete, grade of steel, and all. I can define it from here. I have to go here, I have to go to add new material, and in add new material, I have to click in which region I am working. I'll consider India here. Material type, let us say I'm making use of concrete here, and standard it will be Indian. Let us say I need to make use of M30 grade of a concrete. I'll click OK, and by default all these properties will pop up. We'll not try to get into all those things. We already seen in one of our lecture, and we'll try to hit on OK. and then I'll hit on OK. So by default, I mean, after doing that, you are getting the grade of a concrete here. That is M30 grade of a concrete has come. Click on OK. In the same way, if you want to find the section properties, go to the define. You have a section properties. You can go for frame section. Let us say you want to define a beam of 300 by 550 mm. Sorry, a beam of 230 by 450 mm. So by default, this much beams are going to come. These beams are no use for us. We have to add new beams. So what we do, we go to add new property, go to add new property. From there, take an option called, you have various option. You can make use of concrete, you can make use of a steel beam. If you want to make some special, then you can do that. Then then we have steel composite. So let us say I want to make a rectangular beam. I'll click on concrete, and I can see a rectangular shape here. I'll click on rectangular. So by the default, a window pops up. So the ETAB is asking me what name we want to give. Let us say this is my first beam. So I'll give a name B1. I'll make it in caps B1, and the size is like, let us say, 230 by 450 mm. This is what I'm trying to give. And what is the material you want to use? So since it is a concrete, I need to define the grade. So let us say I want to give M30 grade of the concrete. Now, see, I've given a name here 230 by 450. That doesn't mean that the ETABS will design this considering 230 by 450 size. So this name is given for my understanding. Just I want to, find it when I have a lot of, when I have different sizes of the beam. So this is for my understanding. But if you want to tell ETABS that you want to define 230 by 450 size, then you can see a section properties here. The depth is given, the width is given. What is the depth you require? It's a 450, right? So I'll click on 450 here. I'll type 450 here. And what is the width given? I require 230, that is 9 inch, let us say. And click here and give 230 So now the ETABS will take this section has 230 by 450 Then other than that, you can go to the reinforcement part. Since I'm doing it beam, I have to tell ETABS to design it as a beam. That is why I need to click this M3 design only. That is, it will be designing for moment. That is M33 for the bending. It's going to design. If it is, excuse me, if it was for a column, then I would have clicked on this column. Then it would have taken the P, M2 and M3 design. P is my axial force on the column. M2 and M3 are my biaxial moment. That is M2 moment and M3 moment is what I'm getting. Now coming to the longitudinal bar, since it is a beam, this will be my longitudinal bar, and my stirrups are called as confinement bars. So I'll go to longitudinal bars and I'll see. Right now I have not defined it. That is fine. We have to define FE 500 grade here, and for the confinement bars we have to define FE 415 grade of a bar, because the code says us that you should not use a grade of a rebar more than 415 Newton per square for the confinement bar. And this is for the ductile detailing, and this is the cover that we need to give for the beam, right? So by default, you can put 25 here, since it is a beam, but that is not actually the right way. But we'll put 25 here. That is fine, because it's telling us cover to the longitudinal rebar group centroid. So you have to exactly use the centroid, adding deducting the cover plus half of the bar what you have, that you have to add, and we have to give it here. But it is fine. You can give 25 here, and this you should change to FE 500, and this you have to change it to FE 415. If you want, if you are not done it here, you have another option. Just click here. That will take you to the material property itself. Now I'll add a new property. So this time I'll take it as rebar, that is reinforcement bar, and I'll say HYSD grade 415 is what I want. Click on OK and click on OK. Along with that, I'll and click on OK here. Along with that, I'll define one more property. I'll go to add new material. This time I'll take HYSD 500 grade of a rebar, and I'll click on OK. And I'll by default all the properties will come up. I'll click on OK again. I'll click on OK again. So this time what will happen? You click here. Uh, you click here. That property has generated here. So I'll take longitudinal bar. So it is HYSD 500. Since it is a confinement bar and I'm speaking for the beam, it has to be my stirrups. That is the reason for the confinement bar, we should always use HYSD 415 Newton per square as my rebar. After all these things are done, I'll click on OK, and even all things will come up. The property modifiers will not try to do it. It's a very high level thing. Will not try to do that. These things are done usually when you go for high rise buildings, right? Since in high-rise building, let me explain it. In high-rise building, what will happen? Your sections are going to crack. We design RCC section as a crack section. So when we go for high-rise building, I assume that my sections are going to crack. If the sections are going to crack, then whatever moment of inertia I have, that stiffness is going to come down. In order to take care of that, I'm going to change the property of my material, property of my sections, like the beam, the column, and all. For that, you need to refer the code books. The code book has given a lot of coefficients like zero 0.3, zero 0.7 for the various beams, columns, shear walls, and all. And based on that, we'll try to change the modifiers. But if it is a small building, if you're constructing, let us say G plus 1, G plus 2, or G plus 5, we don't try to play with all those things. Just design it. You don't have to change anything. But only the torsional constant what you have here, that has to be changed. You have to, instead of keeping it 1, you should do it as 0.001. That means what I do is I don't give any torsional resistance to my beam, because I say that my beam cannot take any torsion, so I'm releasing all the torsion. So I'm going to get 0.01 here. So those things usually we do when we go for high rise building. So we'll not try to get into that, but we should have an idea of why all those things are given, right? So you have to click on OK, and you have to click on OK. So by default, whatever name I have given, this name has come here. So I'll click on OK. The same thing, the same logic applies for column as well. The way what I've done for the beam, the same has to be done for column as well. I'll click on OK now. I'll change this to a plan. I'll go to story 1. Let's hit OK. Fine. This is my story, right? Other than that, the spring properties are taken when you want to take the soil into play. Due to the soil structure interaction, we are going to define soil as a springs. So if you want to do all those things, and if you want to give the soil report, input the soil report and all, then you can do all these things. Point springs I have a line springs, I have area spring, I have, if you have a soil profile, you can click on soil profile, you can add a new soil profile, and all this whatever is a profile of the soil, that will be given by a structural consultant. If you want to take those things also, you can do all those things here. But in normal structure, we don't try to play with all those things. Next, coming to define again, diaphragms are usually given to tie the entire structure, and also to transfer the load to the CG. So those things we do once we are done with all the uh, building. Next, coming to the peer labels, pantry all doesn't, we don't make use of them unless we have a shear wall model, unless we have a deep beams model. We try to give these peer labels and spandrel labels. Other than that, yeah, this mass source, other than that, the functions what you have here, it's a response spectrum and time history. These things are done when we make use of earthquake resistant structure. We have three methods. That is, one is um, equivalent static method. The second, we have response spectrum method, and the third what we have is the time history method, right? So there are a lot of theory behind those earthquake design and all. So if you want to make an earthquake resistant structure, in that case you have to go to the function, and you have to try to play with all those things. In a normal structure, if it is not falling in a earthquake resistant in an earthquake zone, we don't try to do all those things. Next, coming to the mass source, even this mass source comes under the earthquake design, where we try to reduce the live load. The code says that if you have a live load more than 3 kilonewton per square meter, then you have to reduce it. So by 25%, and if you have a live load greater than 3 kilonewton per square meter, you have to reduce the live load by 50%. So the reason behind this is that during the earthquake, what happens? We all get panic, and we try to run out of the building. So when we all try to run out of the building, we all are the live load, isn't it? So the live load of the building is going to come down. So keeping that in mind, the code book has been designed in such a way that all these things are captured. So we'll not try to do all those things, but as I mentioned, I'm going to give you overall view of where and how these commands are used. Now coming to the P delta options, we don't use it. I never use that. Model cases, again, it's a place where earthquake resistant structure, what we are designing. In that case, we try to play with these model cases. Load patterns, we already seen how we are going to give the load pattern. By default, I'm having a dead load, and I'm having a live load here. If I want to add let us say a superimposed dead load, that is SIDL, I'll click on SIDL and I'll try to add a load here. Let us say it's a super dead, and I'll try to add a new load. So by this way, what I'm going to do, I'm going to give the load to my structure. This is one way of doing. Then coming to the define again, we have shell uniform load set. These things is used when you have a set of load cases, uh, and when the architect keep on changing the load. Let us say you have a bedroom. As of now, you're planning to put a tiles there, but again after sometimes you feel like you don't want to put tiles, you want to put marble there. So you're a dead weight. I mean, the SIDL load is whatever is there in that bedroom. It keeps on changing. So that is why we try to make certain load set, so that if the architect try to keep on changing, we don't have to go and change it in the each and every of the slab. Whatever load set I have done, based on that we can do it. So usually we don't try to do that. Normal load we try to apply. Now coming to the define again, load combinations is done. I don't have much idea auto construction sequence case, and I don't know when these walking vibrations will be taken into consideration. Next, coming to the draw command, whatever draw command you have here, all the draw command what you have, it's same. The same command is here. If you can see here, see, this is a select object. Look at the symbol here, right? So the same thing is here. Look at this symbol here, the reshape object, it is here. Then you have a draw joint object, that is also here. So whatever command we have here, the same has been given here, right? Yeah. Next, coming to the select option, there is nothing much here. In the select option, let us say I have a building here, but I want to select only the columns, or let us say I want to select only the beams. So then what I'm going to do, instead of going and selecting each beams here and wasting my time, the better option will be go to the select option, and from here go to the object type. What you have to do, go to the select and go to object type. So now the ETABS is asking you what you want to select, whether you want to select columns, whether you want to select beams, whether you want to select null lines, whether you want to select walls or floors. Since I want to select beams, I'll click on beams and I'll say select. So whatever beams I have drawn here, all the beams will get selected in one go. Otherwise, what would have happened? Each time I go here, I have to select each and every of the beam. So the better option is go with this method of select. Right, other than that, the next option is assign. In the assign option, it's all about assigning. If you want to assign the load, then you can go to the frame load. We have seen how to assign the wall load and all. The same option holds good here. So if you want to apply the wall load, then you have to go to the frame and go to the distributed. Suppose if you want to apply the load on the slab, then you have to go to the shell load and you have to go for uniform, right? Suppose if you want to define the frame section, you have a frame section, but if you want to change the frame section, what I'm trying to tell is, let us say I've drawn a beam here, and this beam is 230 by 450, but I don't want that size. I want to change the size of that. Instead of 230 by 450, I want to make it as 230 by 600. So what I'll do, I'll select that beam. Let me do that. Yeah, see, I've drawn a beam here, right? You can see a beam has been drawn. Now let us say this beam what I've drawn, I don't want this size. I want to change the size of this beam. So what I'm going to do, I'll select this beam. It's selected, right? Yeah, I'll select this beam. I'll go to assign. Since it is a frame, I'll go to frame. I'll go to the section property, and let us say I want to name this as B1 230 by 450, and I'll go for apply. No select. Okay, let me do that. Yeah. See, right now what has happened? Yeah, right now you can see that section has been ISLB. Let me do that again. Object assignment, go to the section, try to see that. See, what is the name here? ISLB. Some steel section has come here. I don't want this steel section to happen to be here. I want to give a section of 230 by 450 of a beam of a concrete. So I'll select this. I'll go to assign. I'll go to frame element. I'll go to section property, and I'll say do please assign this B1 property to this particular beam. I'll select this and I'll go for apply. The moment I apply that, what you can see here, the property has changed from ISLB 600 to beam 230 by 450. So this is how the these assign properties are going to work out. This is how the assign properties are going to work here, right? So everywhere, wherever you want to change the section, if you want to change the slab size, everything, you can make use of this assign. Next, coming to the analyze button. In the analyze, once all the models are done, model is ready, you have to click on this button called as run analysis, which we already done. You can do it from here, or there's a shortcut for this which you can do from here. So that is all about the analyze option, right? Other than that, you have a display options where you can display the load what you assign. You can see the deform shape of your structure. All those things we can do it from display option. Coming to the design, so once everything is done, if you want to design the beam, you have to go to design. There's option called concrete frame design. In the concrete frame design, you have to go and start here, start design check. Since we have not done anything, this button is not activated, and since we have not run the model, this button is not activated. But whatever you want to do the analysis, if you want to see the bending moment, if you want to see the shear force, if you want to see how much load is coming on the column, all those things will be done only once you do the design, concrete frame design, and you have to go and do a start design check. So ETABS will start to do the analysis, and it's going to design for us, right? Similarly, if you want to do a shear wall design, you have this shear wall design. Concrete slab design, we have this concrete slab design here. So if you want to do a steel frame design, then you can go for a steel frame design. Now coming to the option, this is all about yeah, how you want to change the graphic colors and all. Like if you want to go to change the display units, right now I'm working on meter. You can see a meter here. You go to the display units. So instead of meter, I don't want that, I want to change it to feet and inches. In that case, what I can do, I can go here and try to change everything. Right now I'm not doing that. Let us say the section property what I have. I was speaking in terms of mm, right? The length is in mm. If I don't want that mm, if I want my uh, depth and breadth of the beam to be in the feet and inches, then I can do that in feet and inches. Similarly, if I come, yeah, forces, stresses, stiffness, time, mass, weight, model factors. So whatever you want to do, let us go for the length, force or length. Length is in meter. Let me convert it to feet now. And I'll hit OK button. So changes has not happened. We'll try to see that. Yeah, the length, okay, the section dimension has come in feet. Other than that, the relative distance, absolute distance. Let me try to do this feet. Not sure if it works out. It's not working. So that is how we try to change it. I'll go to define section property, frame section. Go to this and modify or show property. Yeah, so what you can see here, no? So far what we were doing, we were doing it in mm, isn't it? Now look at here. Since I changed the depth in the section, you can see the feet here. It has come in feet. Before that, what used to happen? I had given the input in 230 by 450 was in mm, and if you remember, I had done a input here of 450 mm and a 230 mm. But by default, ETABS has taken that in feet. Since I changed the unit there, that is why you can see 1.5 feet and 0.8 feet coming here, right? So this is how we can try to change the section properties and all. And other than that option, you have an option called customize toolbar. So let us say you have this draw options here, right? Just in case sometimes if it vanishes, or if you don't want that option here, what you can do, click here, the draw option, whatever, it's already activated, I'll untick it. So what has happened, it has disappeared from here. Similarly, the snap option what you have, I'll untick it. So this snap option what you had, let me see, this is the snap option what I have, right? Let me do it. See, this is the snap options what I have. I'll untick it here. So it has gone now. Similarly, there's an option called select. I'll untick it. So all the option what we had here, everything got disappeared. I'll click on OK. Now this is what is there right now. So how do I bring them back? The simple option is go to options, go to option called customize toolbar. In the customize toolbar, go here and click on draw. So it has come back. Click on the select. So this option has come back. Click on the snap option has come back. Then you have other options as well, like if you want the assign joint. So you can see this as a see these options are already there here in where in the assign. Let me show it and we'll come back here. Okay, see, if you're going to assign, you can see all these options here. You can see all these options here. Assign. joint. You can see all these options here, and same option is activated here. So it's a kind of a shortcut. If you don't want every time to go here and select here, you have a shortcut here. You can make use of them. So what we do, go to the options, go to the customize toolbar, and now let us say I want to assign the frame as well. I'll click on this. So what has happened, this option also got activated. Let us go to assign shell as well. So again this option got activated. Again let me go to edit option. So what has happened, this edit option has come, these edit options have come. Whatever edit option you had here, right, the same, instead of going and clicking on there, a shortcut of that is going to come. Let me say view option I want, so the view option shortcut has come here. Let's say define option shortcut I require. So where is this coming? Yeah, the define option, I guess this is the one which is coming. Yeah, I don't know where it's coming. So define option, whatever is there, it's going to come, and click on OK. So all the shortcuts are going to come here. So this is how we try to, you know, customize the toolbars. Other than that, forget about the help. These are about the ETABS. ETABS is a company. It's a CSI company, Computer Structures and Incorporated. Hashraf Habibullah is the person who, who is the CEO of this company, if I'm not wrong. And so if you want to know about ETABS and learn from the ETABS, they have few of their tutorials. You can go and do all those things. You can watch and learn. If you have an internet connection, you can do all those things. Tools, it's a plugin given, like CSI have their own detailing software nowadays. If you want to add those plugins and all, you can go and add them. I think I've explained everything. There's nothing left here. In more depth I've explained you everything. Each and every command have been explained. uh, just the thing is, you have to watch the video again, try to understand them. What is the practical importance of each and every of the command? You have to practice them. Only then we can try to, only then we'll be able to understand this. Yeah, so other than that, I don't feel there is any other thing to explain here. This one story option I already explained you. If you want to work in a single story, let me do that, not a big issue. Yeah, what I'm trying to tell is, see, I'll click on the beam option. I'll discard this. I'll click on the beam option. Right now I'm on the one story. I'll come here. Right now I'm on one story. So if I'm drawing a beam here, look on the right side as well. What has happened? Only one beam has come. Since, right, only one beam has come. Yeah, only one beam has come. Why is that? Because I was working on one story and I was working on story 2. That is the reason in the story 2 you can see a beam. Now let us say from one story I'm going to all stories, and then I'm trying to put up a beam. So if I'm putting a beam here, now look on the right side as well, on the right 3D window, you can see, so everywhere the beam has come. Why is that so? Because I'm working on all stories. Whichever story you work, whether you work in story 2 or 3, you click on a single, you put a single beam on the right side in the 3D, everywhere the beam is going to come. So this option becomes handy when you work for a high-rise structure. Let us say you have G plus 10 and G plus 15 stories, and there are 5 stories where you have similar beams and similar columns. In that case, you can work on this, right? uh, yeah, so I hope you have understood up to here, and you have got a knowledge regarding all the commands that we try to use here. And other than that, the other options, there are many options, like see, if you click here, this is an option where you can check your bending moments. This option will be activated only once we do the analysis. Right now I'm not doing an analysis. When you do the analysis, you can see this will give you the bending moment. This will give you the support reactions, which you already seen, that how much reaction is coming on the footing. This will give us what is the what is the floor finishes and live load that you have applied on your slabs. This is going to give us the load that is coming on the beam, or how much load is coming on the beam, what brickwork load you have put. Those things you are going to get from these options, right? And this option we have seen, 3D plan elevation option we have seen. This button will take you up and down. If you're in the second story, if you click here, that will take you to the third story. If you click here, that will take you to the fourth story. The down button will take you down to the, will take you back to the below story. So this is how this options has to be activated. And then coming to this particular options, it is a very important option here. Now let us say these are the ISLB sections. Now let us say I want to see what section is this. Then what you do, go to the object assignment, and since it is a frame element, you have to search under the frame element and click on this section properties. The moment you click on section property and try to apply that, yeah, see by default that section has already come. Let me do it. I'll take one more beam. I'll try to put a beam here. Yeah, so by default that option is, see by default the section is coming, that is it's a 230 by 450 section. Let us say I don't want to see this, you have to just untick it and put apply command, so everything will vanish. Just in case you want to see it back, go back to um, yeah, go back to this option, the tick option, and then come to the object assignment, and there's option called section. Click on the section and put apply, click apply, so these sections are going to pop up. So with this we'll understand, like when you're working in big projects and when you have many beams, like 2 3 different sides of the beam, it will be difficult for us to identify. Then this option will come into play, and we can make use of this option. So there are a lot of options here. So this is how we usually try to play with. Now let us say you have a beam visible here. If I don't want to see my beams here, then you can go to the general option. You have a beam here. Right now it is ticked, that is why you are able to see it. You just untick it and apply here. So what has happened, the beam has been vanished, the beam has virtually vanished, right? I mean actually there is a beam, but as of since I unticked it, it is not showing here. But if I tick it, if I check it again, and if I put apply here, what will happen, the beam is going to come back. So in this way, whatever, like if you don't want the column to see, if you don't want your floors to see, if you don't want your walls to see, so all these things we can try to play from here. Other than that, rest all, yeah, these are the dimension lines and all what you can see. See see, you are getting a kind of a grid here. You are getting a kind of a grid here. Let's say I don't want to see this grid. Then there's an option called horizon here. It's a horizon. Just click here and put apply here. That will get vanish, right? Similarly, I'm getting a dimension line here, 8 meter, 8 meter, and 8 meter, right? If I don't want to see that, just click on the dimension lines here. Just untick it and apply here. What has happened? Your dimension lines have vanished. And if you want to bring it back, just click on the dimension lines again and try to apply it. So those dimension lines are going to come, right? So other than that, other things I've already explained. If you don't want to see your columns, you can tick here, and you don't, I mean you uncheck it here, so you'll not see your columns. We'll try to do that well as well. So that would be the last thing. So we know how to put a beams here. Now let us say uh, I want to put a column. So what is the option for a column? You can see option here, quick draw columns. Just click on the column and you have to select a column from here. Right now we are not let us say yeah, there's one column here, concrete column. By default the concrete column is coming. I'll select on the column. The moment I select, a kind of column is coming wherever the grid line is going to meet, that is the A grid line and the 4 grid line, where it's going to meet. Just tick here. I mean the moment you keep it here, you can see a grid point A comma 4. That means it is exactly at that A comma 4, and just click there. Your columns are going to come. Again I'm going to click it here, it's going to come. You can see on the 3D side as well, the moment I click it here, it's going to come. Now why is that it is coming in the entire structure? Because I'm working on all stories. Now instead of all story, I'll go back to one story, and right now I'm in story 2. So if I click here, only in the story 2 this column is going to come. You can see here the column has come only in the story 2. I'll place it here. You can see the column has come only in this story. So whenever we want to model the columns and all, this is how we try to model it. So I'll click it here. Again a column has come here. So this is how we try to put the column. Now the last thing what is to be explained is about the slab. Now you can see these three options, that is draw floor wall, this is another wall, and this is another slab what we can model. So this option if I take, so let us say I'm taking some slab, the name of the slab is S1. So this option will be useful when you're going to select all the points. Let us say I'm selecting this point, then I'm dragging it from here to this grid. From there I'm going to drag it to this grid. From here I'm going to drag it to this grid, and from here I'm going to drag it to this grid. So what has happened? A slab has come here. The same can be seen here. A slab has come. This is one way of drawing. The second way of drawing is, this is the one. Just click here and from here you have to drag it in this way, and wherever you want to stop it, you can stop it. So the slab is going to come. Let us say I want to drag a slab somewhere from here to here. In this way I want to drag a slab, so I have dragged it and I left it, so you can see a slab coming up. Now let us say I have one more option, that is a quick draw. So this will be handy. You don't have to drag and all, just go there and click here. The slab is directly going to come. What you have to do, just go wherever you want to put a slab and just hit that left button on the mouse. You're going to get a slab. This is how you're going to get a slab. So based on the work that we have, we try to use these slabs, whether you can make use of the first method, the second method, or the third method. Similarly, if you have walls, the shear walls or the wall, this is the option what you can see, draw walls. Click on the walls and try to draw the wall in this way. You can see a wall coming up here. So this is how the wall is going to come up. Yeah. Now what I'm going to do, instead of one story, I'll put all stories and I'll try to draw the wall again. So now what has happened? Everywhere the wall is coming. You can see the wall coming. I'll try to draw it here again. You can see the wall coming, and here also I'll try to drag it. So what has happened? A kind of shear wall has come up here, isn't it? So it's a kind of a shear wall which has come here. So this is how we try to draw the wall if we want to put the shear wall or a retaining wall. So this is this is how we try to make use of this command. And coming to this command, so it's a quick draw. You don't have to drag, just like the option what you had here for the slab, the same option is here, but this will put up a wall. So simply you have to keep here, a wall is going to come. Keep it here, a wall is going to come. Put it here, a wall is going to come. Put it here, a wall is going to come. Put it here, a wall is going to come. See, let us draw wall everywhere. On the periphery wall, a wall is going to come. A wall is going to come. So this is how we try to model any building, or let us say you want to put a kind of retaining wall. This is how we try to put it. Let me put wall everywhere, so that you are getting a kind of structure in this way, right? So this is how we try to model. I hope I explained you each and every of the command here. We'll see you back in the next lecture. Thank you.